Hello, I'm Phil. I am, for those of you who have missed, there's people I don't know, so I'm introducing myself. I'm Phil Levin in SEFS. I'm also lead scientist for the Nature Conservancy here in Washington, and it is a true pleasure to introduce actually a mentor of mine, Ryan, for real, Ryan. So when I came here, you know, I'm a marine biologist, and I started this job at SEFS, which is also kind of weird. And I thought like Doug Fir referred to like beard on my friend Doug. But Ryan taught me what a tree was. And I'll be forever grateful. I know that there's more than one kind of pine. I don't know if you know that. There's many different species. I owe Ryan for all that. What made him qualified to give me such profound wisdom? Well, it started off at St. Olaf's College, right? In the late 90s. It was a beautiful place to learn about biology and become inspired about the world. But that's in Minnesota, if I'm correct. And Minnesota used to be a cold place, and I guess still is. And that brought him here. And many of you probably know that he did his master's degree here. That took several years. And then he did a PhD, more years. After that, he did postdoc here, more years. So he actually, there's people in this room who are far more qualified to introduce than I am. I'm just making stuff up. But he spent a lot of time here, and I think did a lot of really interesting and good work on the topic we'll talk about today. And he brought that skill set over to the Nature Conservancy, where he worked as part of our forest team for many years. And he honestly did like actually take me to a forest. I'd never been like to a forest, and he showed me the trees, and he taught me about forest management and fire and stuff like that. So he actually has been profoundly influential to me in my recent career. He left, sadly, Washington TNC, and to become, luckily for Oregon, the science director for TNC's Oregon chapter. So they are lucky, it's our loss, but I'm happy that we still get to work with him. And I'm still happy that he has a lot of collaborations up here with people. And on top of being a great scientist who's very generous with his time, he's also been a wonderful colleague. And I'm really happy that he's here to speak to us today. So, what do you take away, Ryan?
Thanks for that introduction, Phil. Thanks everyone for having me here. It's great to be back at SEFS, although I don't think it was ever called SEFS while I was here. I was going through a bunch of name changes, CFR, SFR. I think I left before the SEFS era, so anyway. So like Phil said, I'm gonna give two stories, talk about two studies about my work with the Conservancy. Hard to read that back there, but it's an interesting world that serving as a conservation scientist for a non-governmental organization, it's really cool. I tell people it's working at the intersection of applied science and land management and biodiversity conservation and public policy and human well-being. So it's very different than my experience working as an academic here at UW. It's different than the time that I spent working for state agencies. But it's a really unique and inspiring and really enriching sort of set of challenges that we get to tackle. Okay, so just a very quick background. Phil mentioned the Nature Conservancy a bunch of times. We are, I think by dollar value, the world's largest conservation NGO. Today we're working in something like 60, 70 countries around the world, all 50 states. It's a big, complex organization. But at the heart of it, we were started by a group of ecologists from the ESA and Outshoot in the early 1950s. And so from the very start, science has been at the core of what we do, of our conservation mission to conserve the lands and waters on which all life depends. This is a screenshot from Conservation by Design, which is sort of our guidebook for how we as an organization, we're not a science organization, we're a science-based organization, how it is that we weave the role of science and the role of working from a rigorous evidence base to take conservation action for all that we do. I just want to show some old photos here, but my years here at UW in forestry were really tremendous. There's John Bacher holding up a shovel. He was teaching me how to be a great field ecologist. So John Bacher, Charlie Colburn were my two advisors while I was here. And I really just had a tremendous experiences here. Highlight of my own, my personal athletic career was when our ultimate frisbee team won the UW IM championships sometime in the early mid-2000s. That was really the highlight of it. No, that was great. But I just want to say it's the tools and the experiences that I gained here as a student and as a postdoc have really served me well launching into my career. Okay, so getting down to the studies and the stories that we want to talk about. Not a surprise to any of you. I'm sure you're all very well versed of the role. In many of our forests across the Northwest, fire historically, naturally plays an incredibly important role in structuring and maintaining these forest ecosystems. In that, in recent decades, we have seen a tremendous increase in the experiences of fire in our forests in Washington State, in the Northwest, and across North America. These trends are driven by a number of factors, including the role of fire suppression throughout the 20th century, our climate variation and long-term climate change. And also anybody who watches the news, you know about the tragedies that can strike when our homes, our towns, and our cities come interface with ecosystems that rely and that are dependent upon fire. So this was a photo taken, I think, from Carlton Complex in 2014. Since that time, we've just had so many other tragic stories here in the Northwest, in California this last fall, and it really is something that, in our conservation world is really dominating our conversation and dominating our understanding of the relationships between people and nature. I want to talk about in the Northwest here, it's not just the tragedy of people losing their homes to fire, but because fire is such a fundamental component of our forest ecosystems, we rely on these forests for so many things. Millions of people, the tremendous fish and wildlife habitat that they provide, recreational, spiritual opportunities, economic products, really millions of people in our communities across the West depend upon these forests. And because fire is an essential component to these forests, it impacts all of these values which we depend upon our forests for. So this changing relationship with fire and our forests has really driven a profound change in our management of forests in recent decades. And we've entered an era now where, at least on our public forests across the West, we are seeing ecological restoration as the dominant management paradigm, using tools like controlled burning, mechanical thinning, to restore the natural role of fire into these forests, to try and restore ecosystem process and structure. And for 10 or 15 years, for the Nature Conservancy, this has been one of our primary approaches for achieving conservation outcomes in our dry fire-dependent forests, ecological restoration. Well, at least when I started my role with the Conservancy in 2011, we were working in this paradigm of ecological restoration. We were working with stakeholders and partners across the region to promote restoration, but we were left with big questions at that time of trying to understand, okay, at a small scale what we want to be doing. We want to be restoring the role of fire to these forests. We want to be trying to restore ecological resilience, however we define that. But what does that mean when we scale it up? Where, what kinds, how much management do we want to do to pursue those goals? And at the same time, we are also wondering, okay, so what is the role of wildfire in pursuing these goals of conservation and resilience? And so what I'm going to talk about are two closely related studies that were working to address those questions. Where, how much, what kinds of management, and what is the role of wildfire in our forest today in our desire for conservation and resilience. So the first study I want to talk about was a collaboration between the Conservancy and the Regional Ecology Program, the U.S. Forest Service of the Pacific Northwest region. It was a study that was published a number of years ago now, 2015, and then recently updated in 2018, again with Nature Conservancy and Forest Service colleagues. And this was really to address that question of, if restoration is the goal for our forest landscapes across the Pacific Northwest, what does that mean in terms of management? Where, how much, what types? So at the root of both of these studies were several core inputs that we used. At the core of this was mapping forest ecosystems across the region. To do that, in these studies we used the potential vegetation type mapping product that was developed through the Integrated Landscape Assessment Project. A lot of words, but this was really a compilation that was put together back in 2012 and 13, taking the bench mapping from the many efforts that have been conducted across the region, stitching them together as best was available at that time. And we're going to talk more about this, but we also wanted to be able to model what the natural or historic functioning of these forest ecosystems looked like. So from that, we drew from the Landfire Program, which is a national collaboration amongst the Conservancy, U.S. Forest Service, USGS, and others to use their biophysical setting models. These are fairly simplistic models to capture the functioning of our forest ecosystems. And that simplicity is really both the benefit and the limitations that they provide. We'll talk about that. We map forest conditions across our region using the Gradient Nearest Neighbor product produced again by the region and Oregon State. It's very commonly used in forest planning efforts. And then a set of sort of logic tables that we developed. Okay, so what does all this mean? How did that come together? It's just a lot of words for our methods. So at the heart of this, again, were these biophysical setting models. And so it was taking our different forest ecosystems and separating them into different developmental stages. Early development, mid-development with open or closed canopies, late development with open or closed canopies, as a very simplistic framework that we could generically use to describe different forest service or different forest ecosystems across our region. And then all these arrows represent deterministic processes like growth and succession, stochastic processes like fire or insect, disease, wind. And we developed, we didn't develop, but we used models developed by the Landfire Program to capture the influences of those factors in each of our systems. So what that looks like is, if you go from Seattle, you drive up to Snoqualmie Pass and then drive from Snoqualmie Pass down to Ellensburg, you'll be passing through a number of very distinct forest zones or ecosystem types as you head down that gradient of the East Cascades. Each of these different forest types, different species composition, different habitat values that they provide, different relationship with fire. So taking, for example, the dry mixed conifer zone, which is the focus of much of our efforts across the interior. So within that dry mixed conifer zone, when we model the natural range of variation from that state and transition model, again, we have our different successional classes, and we develop a range of relative abundances for each of those classes. The classes by themselves, they're not good or bad from a conservation or management perspective. But with these models, they allow us to characterize this ecosystem based on the relative abundance within a landscape unit. For this particular type, it's characterized by mid-development, late development, open canopy structural types, with very little of mid-development closed. So these models were constructed for each of our forest ecosystem types. I think we used 27 or so across the Pacific Northwest region. Each forest type had a different natural range of variation reference condition that we assessed. So then within each forest type, within each landscape, we then compared our reference model to conditions on the ground today, again, using the gradient nearest neighbor data. Here we found, this is This is one example from a watershed in the East Cascades of Washington. Comparing the green boxes are reference to present conditions on the ground today, the blue bars. Some of these successional classes, the amount of mid-open on the landscape today is relatively in line with our reference model. Other places, we have dramatically more of that mid-development closed canopy, dramatically less late open than we have in our reference model. And so the logic approach that we built then evaluated the sort of which successional classes had an excess in particular landscapes, where there were deficits. And the way we defined management or restoration needs in this approach was to say, so within a system, within a landscape, what types of changes need to occur over time to rebalance this model, to take the developmental types where we have an excess, and somehow change the trajectory of those systems to move the excesses to fill in the deficits. We developed a set of logic rules to say, for any particular imbalance, to go from one successional class to another, what type of ecological change or management change would that be? A combination of either reintroducing disturbance, allowing successional processes to take place, or the combination thereof. So what that means are, again, some of the imbalances we may be able to, by introducing disturbance today via thinning, via fire, via the combination thereof, make the transition happen today. Others, it's no action is needed, it's just time is needed to regrow forest structure, or some combination of needing to reintroduce disturbance to change forest structure, and then also time to regrow older trees. So we developed these inputs, we developed these logic models for every forest type within every landscape across the region. I think that was something like 1,400 combinations of forest types, landscapes. We run this through an automated process. And what we see when we see some very significant, very distinct trends. The map on the left here is looking at what we call disturbance restoration needs, or locations where some type of disturbance to open up canopy or to move from an older to a younger successional class is needed to help return landscapes to a natural range of variation reference condition. You can see, not surprisingly, that the darker red colors, disturbance restoration needs, they were highest in regions characterized by large extents of dry, historically fire-dependent forests. Interestingly, when we look at successional restoration needs, so areas in which we are needing to regrow older, later development structures. In some places, they overlap with our disturbance needs. Elsewhere, you see the impact of our land management, our history of land management. Washington, Oregon coast, where we have extensive industrial forests, forests held in plantations held in young states. That clearly comes out on these mapping. So before we turn to the interior fire-prone part of our region, looking first at the west side, when we summed up these values for Western Oregon, Western Washington, we found that it was 30% of all forests, nearly 7 million acres, where to return to that reference condition, if that is our goal, forested acres need to then grow into a later development class. And by and large, that was, it was not a need to open canopy. It's not the same as our dry forest story, but it's really just growing those old, complex, closed canopy forests that once were very abundant in these west side ecosystems. And I should say that's not entirely a passive process. Photos from the Conservancy's Ellsworth Creek Preserve in southwestern Washington, where we've been experimenting with using tools like commercial thinning to accelerate the development of complex closed canopy stand conditions. But really the big story, the story that we talked most about though is on the interior, where the departures, the restoration needs were even higher. From this, 40% of all forested acres, or 11.5 million where the present successional class on the ground today need to change into something different to return to the natural range of variation reference conditions. And this is really dominated again by the need to return disturbance to these landscapes, where it was needing to put disturbance on the ground today, 3.7 million acres, or a combination of disturbance plus regrowing larger, older trees, dominated the restoration needs across the interior and southwest Oregon. So these are really big numbers, and they've gotten a lot of attention, I should say, in the policy sphere. And I think this approach has been useful to set the context or the big picture of the condition that our forests are in today. But I always want to stress that this study by itself does not provide an answer for what a land manager or conservationist, what a landowner should do in any particular forested acre. So for example, this is Pete Laird. He's on a timber marketing crew from Okanagan, Wenatchee. And so while the study sets the big context for a statewide to regional scale, there's been other tremendous tools at our disposal for how do we then understand at a watershed scale or at a single stand scale, how do we achieve our goals of restoring ecological structure, process, and resilience. So here Pete was at a workshop that we were putting on using the individuals, clumps, and openings marking technique that Derek Church, who many of you know, Andrew Larson developed partially during their time here at UW. So at the stand scale, when we go in, how do we know if we're trying to restore structure and process to this particular forest stand, this is a state wildlife area outside of Cle Elum, which trees to cut, which trees to leave. The orange paint that Pete is putting out there is indicative of that's a leaf tree during that project. So he's saying that's one of the trees that'll be left. So point here being simply that there are important bodies of science and tools to use as we get down to the sort of implementation scale for these restoration objectives. I also want to promote how incredibly important it is to be able, to not just use tools like thinning, but also be reintroducing fire as part of these dry forest restoration approaches. Really, without fire, it's not possible. Some land managers would like to be able to restore without fire, but it's that second step of returning fire that really is essential to the process. So the final piece I want to say on this is it has been exciting, interesting, sometimes daunting to see the traction that these studies that we produce with the Forest Service have had. For example, Washington DNR, both in 2014 producing a report to the legislature, a recent 20-year Forest Health Strategic Plan, have both in part been able to build on these broad-scale, statewide studies that we've produced. So I'm going to switch gears, talking about proactive restoration, to then asking, so what is the role of wildfire in trying to achieve our own organization's goals of conserving biodiversity and ensuring the resilience of our forest ecosystems? When we know right now that the footprint of our proactive management in forests across the region, on the order of tens of thousands of acres, while each in recent years we've been burning hundreds of thousands of acres per year. And it leads to the question: to what extent are the wildfires that we're experiencing? To what extent are these fires within a range of conditions to which native ecosystems are adapted and thus might be promoting the resilience of our systems? And to what extent are these fires occurring outside the range of conditions to which ecosystems are adapted and thus potentially destabilizing our ecosystems? So this question of to what extent are the wildfires we're having characteristic versus uncharacteristic for our native forest ecosystems, that was the key question we asked in a follow-up study. Again, looking at all the fires in the Pacific Northwest from 1984 to 2015 and comparing those to those same historic reference models that we used in our previous study. And so in this study, we talk a lot about historic fire regimes, which again really is just the, within these forest ecosystems, what was the pattern of fire activity that occurred naturally over very long time spans. So to conduct this study looking at contemporary to our natural fire regimes within our Northwest forests, we use a very similar set of inputs for these studies. First off, again, mapping forest ecosystem types across the region using the same, or using an updated set of the same land fire and biophysical setting models to set our reference conditions. And then working with the monitoring trends and burn severity data. I want to note for the fire books here, we did a fairly intensive reprocessing of the fire severity data to correct for many of the known issues within that data set and to have consistent definitions of low, mixed, and high severity fire from fire to fire from year to year within the data set. So now I'll have an effort to update and correct for issues within these nationally provided data products. And what we found when we compared our models of historic fire regimes to what we've been experiencing over the last 32 years at an ecoregional scale is, first off, some really tremendous deficits in the amount of fire that we've been having. So even though we've had an increased area burned the last few decades compared to mid-century, so within our forested systems across the Northwest over this 32-year period, we have about 3.9 million acres burned when we subtracted for all of the unburned areas within fire perimeters. And this is including all low, moderate, high severity fire. And that compared to our expected area burned in our historic models of somewhere between 36 to over 40 million acres. So it was an order of magnitude deficit. It was just tremendous. And it wasn't just that the deficits were large, it was also that the patterns of severity that we're seeing in our contemporary fires are out of whack, or they deviate from what we had in our reference models. So proportionally, we were looking at, in our dry and mixed forest types, there was more high severity and too little low severity fire compared to our reference models. And surprisingly, while the deficits were smaller in our wet and cold forest types, in the fires that we have experienced, there's actually a proportional deficit of high severity fire. So by and large, the trends from this study, and I keep saying this study, it's not published yet, we're in our second round of reviews at a journal right now, so I'm just realizing if any of the reviewers are in this room right now for the study by chance, thanks for all the helpful feedback. I hope we're through just about. So this will be coming out soon. But again, the trends in this study really have been driven by these large deficits of low severity fire in the dry forests, which were characterized by frequent low severity fire. So again, it was a huge deficit, between 18 to 25 million acres deficit of low severity fire in those forests. And when you looked at the relative proportion of severity over the last 32 years, it's been close to 36% of the area burned has been at high severity in these dry forests, compared to our reference models of somewhere between 6 to 9% would have been proportionally high severity. In our forests, which were characterized historically by mixed severity fire regimes, there were deficits, but they were relatively smaller, roughly 2 to 4 million acres. And again, there was a slight skew towards a higher proportion of high severity within those mixed regimes compared to the reference models. And we looked at our forests, our wet cold forests, historically characterized by high severity regimes. There was a deficit, but it was relatively small, less than 1 million acres. And again, interestingly, the proportion of high severity was less than was expected from the reference models, which initially was confusing, but in discussions with our team potentially makes sense. in terms of oftentimes these are the easiest fires for fire managers to let burn. When they're at higher elevations, moist conditions, those are relatively easier fires for a manager to let go. Those are points that were brought up. I can't speak to that directly, but we spent some time scratching our heads trying to think through how and why that result may have been. But thinking about the takeaways for this work, I mean, just the magnitude of the deficit shows that, you know, certainly humans have altered the extent and the severity of the fires that we are experiencing across our region. I don't think that was, it wasn't a question that we were influencing our fire regimes, but just the extent to which was still surprising. It's also showing that despite the fact that we've had, you know, very large fire years in our region recently, they're not necessarily, you know, on a whole scale, restoring our ecosystems if the severity of those fires are out of whack compared to what our systems are adapted to. I also want to note that it's not just the amount of low, mixed, or high severity fire, which is what we evaluated. The spatial patterns that are produced by those fires are incredibly important from an ecological perspective. How large are the patches? What's the configuration of habitat patches left behind by a fire? That was not something we addressed in this study, but it is definitely important from a land management, from a conservation perspective. And then this was completely a retrospective study. So with climate change, we know that we're going to be continuing to increase the area burned in our region. We don't really have a choice about that. But it does bring up the question, you know, what will the severity be of the fires that we experience in the future? And then so the applied takeaway that we have from this is, while there were deficits across all of the forest types and across all severities, it reinforces the idea of needing to find avenues to promote low and mixed severity fire in our dry forest landscapes. And I also think that there are some difficult implications potentially from this work. You know, just thinking about, we always raise the question, this was again a retrospective study using historic models. Should we be advocating for historic fire regimes, or is our climate changing, you know, such an extent that a historic model, what does it mean for the future? I also think that in advocating for historic fire regimes, you know, can we tolerate, you know, should we be, the amount of smoke that would come from burning the number of acres that show up in these reference models. We've all, you know, in Seattle, living in Portland the last few summers, the smoke has been a very real impact in our lives. You know, and that's not to say people living, there are communities which are much more affected than we've had in our, you know, in Seattle and Portland. It's a very real impact on people's health and their lives, on economies. And so, you know, thinking about the role of smoke in the management and conservation of our forests it's a really big, gnarly question. And then again, it just highlights the difference in scale in which, you know, through our proactive management, there's just a discrepancy between the footprints that we're impacting, influencing today, and the scale of the disturbance regime, the historic disturbance regimes that we're modeling out. They're disparate today. So with that, coming to the close here, I want to say that this has been, you know, these three studies have been a body of work that the Conservancy that we've been tackling for a number of years. They've been very influential in guiding the direction that we've tried to take. Some of the big questions that we're thinking about now, you know, as we're continuing to look at ecological restoration as a conservation tool, we understand, we feel that we know we also need to look at, okay, so what are the broader implications for other ecosystem services besides the forest themselves, for water, for timber, for air quality. I see Emily sitting in the back, and she's got an awesome study going on right now looking at taking these concepts and looking at relationships with snowpack and water dynamics. And I think that's an incredibly interesting and important direction for our thinking to take. And we spend a lot of time trying to understand how this relates to not just the role of wildfire from an ecological perspective, but thinking about what it means for the resilience of communities, what it means for the economics of treating and managing our forests. And these are also incredibly difficult but important questions to the application of these ideas. So with that, I'm going to step away. Thanks for listening, everyone, and I would love to tackle any questions on any of this. So thank you. Brian?
Right, that was awesome. And I'll just say, I'm not, just full disclosure, I'm not one of the reviewers.
Oh, good. I was here.
But one of the things I was curious about is when you showed the deficits of overall fire, but the high proportion of high severity fire, how do those two numbers shake out in terms of the overall area of high severity fire in some of those other areas? Like, can we cross that off the list and say, like, that deficit is not something we need to worry about anymore? Or is high severity fire still even at a deficit?
No, it's a great question. From that study, in all but one of the ecoregions across the Northwest, high severity fire was still at a slight deficit in the dry forest types. But it was dwarfed by the deficit of low and mixed fire in those systems. So, I mean, it's a nuance, it's an interesting message saying that while we haven't necessarily, over these 32 years, we have not exceeded the acreage or the area of high severity fire that we would have had in a naturally functioning historic regime, the proportions are different. And there's also then the question, if you sort of tie the first and the second study together, because of our past management, because of our history of harvesting, we're also already lacking in complex late development forest structures in nearly all of our forests across the region. So if we are losing those to then high severity fire, there's trade-offs that need to be evaluated. Yeah, Ernest.
Great presentation, Ryan. One question I had is the role of PNC on these policies. I was sorry to see you moving south to Oregon. You're here in Washington, Yakima.
Yep.
But given the role of PNC worldwide, and especially in the Northwest, of trying to influence policy, how do you see it seems like you have an easier job in Oregon. How you compare that, and how we can go about to bring forward the PNC ideas in the state of Washington? We're moving slow. In Oregon, it seems like the governor goes to these fire meetings, conferences, and you see him talking about the sky fire every day.
It was interesting that Oregon and Washington, they like to compete with each other, which I think can be good. Just literally yesterday, I was in a discussion where, let's see, there's the last slides here, where the now people in Oregon are bandying about the Washington's 20-year forest health plan. How can we get one of these in Oregon? So I know in Washington, on the policy front, this was one of a large effort that we had for a number of years, was working with our state agencies to really work on cultural and objective changes to try to bring our state agencies in Washington to be more comfortable, more willing to use fire as a management tool, to pursue restoration outcomes. I think this was there's been tremendous movement in Washington in that direction. Now, Oregon at a state level, I would say the national forests in Oregon have been very proactive in using fire and pursuing restoration. Our state agencies have been less so. So that's a discussion we're having in Oregon right now is how can the Conservancy, what can we do to help enable or promote a similar shift in state level policy in Oregon is one example. It's also really interesting working with this organization because, as you know, I mean, we go from here in Washington State, we own and manage 70-some thousand acres. I mean, we're on the ground. We work with all, stakeholder collaboratives in the national forest, all the way up to, we have a lot of the folks in DC who work with Forest Service leadership at a national scale, and so it's been interesting to try to have a really direct line of communication to take our lessons that we've learned locally, working on the ground, all the way up to the people that we have in DC who are working with the chief and the leadership of the Forest Service to understand and how can we guide their budgets, their incentives, the direction that the agency is taking at a national scale. So, is that?
Yeah.
I was curious, in your first study, can you explain more about reference conditions? Is that a reference condition that's based on a previous climate? Or how does that play out in a world of non-stationarity?
Yes. Okay. So the way these reference conditions were developed, they were so again, behind the reference conditions are these state transition models based upon, for each forest type, different successional stages, and then the potential transitions between those. Each of these transitions are represented by probability. Those probabilities were determined through a massive effort that the Land Fire Program undertook to compile both available published literature and expert opinion to calibrate and parameterize how these systems would have behaved prior to Euro-American settlement. So they're not targeting 1880 or 1890, but they're trying to target sort of the suite of climatic conditions that would have been present, for a several century period prior to Euro-American settlement. Obviously, you can imagine there's a big fudge factor there. Like they're useful tools that are relatively simple. So it's not there's not like a feedback with a climate model into this vegetation model. But they do a good job of capturing the course dynamics, I think, of these systems in a pre-settlement era. The question of, as we're moving into future climates, what does that mean? That is a big question. I tend to think that if we look again at our dry forests, and we see that the difference today versus their historic models is, greater abundance today or less drought resilience, less fire resilience. We're moving into an era with more drought, more fire. I tend to think that the historic models at least are providing us a trajectory for defining resilience on these forest landscapes. But I mean, at the same time, it's something I grapple with as a scientist. Understand, like, how far can we go in using historic models? At what point? But if we don't use historic models, what do we go to next? And in terms of our efforts to bring together stakeholders, other conservationists, industry, local government, recreationalists, having a historic model is something that people can wrap their minds around and we can find common ground. As we move from this to some type of future range of variation or some kind of future climate approach, that finding that common ground becomes more difficult. So I'm only saying this as I want everyone to put their brains on this because.
And I guess to that, my broader question, not being a forest ecologist, is that I have no sense of, your subsequent graphs that show what the deficit is in the different classes. I have no sense of whether I should still believe the target conditions for the next 50 years. For example, if you think of the references as your targets, can you just talk a little bit about how the projected climate change would affect the relative distribution across those classes, or is that just a mystery?
Well, I think I go back to my previous response that, so the difference between reference and current condition for this example that's on the screen is decreased resilience if we want to keep this as a forest ecosystem and not transition into something else unforested. Decreased resilience to drought and to fire. And so again, I guess I'm saying I don't know how the green boxes will change in the future climate, but again, I guess it's the idea that this historic model represents a movement in the right direction to address where climate may be going if we want this forest to stay if we have a forest ecosystem versus transitioning into shrub or grassland or something else. So I feel like it's not a very rewarding answer because we don't have great answers to that today. Good?
So, well, just to follow, so like if it was a marine system, the way we would do things, we wouldn't care because it's all underwater.
Just teasing.
And I'm not quite sure I'm following how you derived your reference state, but what we might do is try to say, what should the reference condition be in 50 years from now? So we use select the data historically, let's say under a certain PDO regime. So if you have certain time periods where you think this is closer to the future, or use some other modeling techniques and data evaluation techniques that allow us to essentially provide almost a counterfactual for future evaluation. So what would the situation be if we did nothing?
Right. And so I should say there is not at the ecoregional scale, at the scale of our sort of individual landscapes, we have a different suite of reference conditions we use. Building a lot of work that Paul Hesberg and others have developed here in the Northwest. And there we have a concept that we use, it's called future range of variation, saying that if we have a counterfactual in which climate change happens, but 20th century management did not happen, where would these ecosystems go? What would they look like? And that provides a different reference condition. And so using a totally different suite of data, so not design fire models, but using this other approach that we're using, the watershed or the local landscape scale, we evaluate both the natural range of variation, we call that future range of variation, and we try to see is there overlap or how similar are those two ranges, and we use that to set our management targets. In that instance, we're drawing from, again, a totally different set of data. That was drawing from mapping of forests back in the 1930s when aerial photography was first available. All of that mapping was stratified by different ecological subregions. And so there, similar to what Phil's saying, it's taking mapping from one ecological subregion and then comparing what the reference conditions look like in a sort of one next warmer and drier ecological subregion to set that natural range of variation to the future range of variation. So, yeah.
So I have a strategic planning question for your organization.
Yes.
Which is more feasible, trying to restore natural conditions on the east side or natural conditions on the west side? And how would you best apply your money to achieve one of those?
So, that's quite the question. I will say we have spent the last decade primarily focused on the east side. Interests in climate and the climate mitigation potential of our forests are driving sort of new focus on west side forests. But on east side forests, we've developed sort of an approach focused primarily on collaborating on public lands. On west side forests, the need for ecological restoration on at least federal forests is not as great, relatively speaking, based on this. It's not that it's not there, but there's not as much opportunity for change management. And on private forests across the west side, which are a larger percentage of the land base, apart from kind of the small footprints of where we have been buying, protecting, and managing lands, which that's been very strategic. Like up on the Olympics, we've been protecting lands within the riparian corridors of major rivers. That's a very expensive approach to try to change land management. So I think we're in the process of trying to think through, are there other levers that we can use on private lands, on private forests on the west side? And there's nothing that we're acting at scale at this point in time on the west side, in comparison to our public lands focused east side strategies. I also want to point out, looking at James back there, on the east side, we also have a sort of parallel strategy of buying and protecting lands on the east side. Maybe you've heard about Washington back in 2015, our purchase of 50,000 acres of checkerboarded Plum Creek timberlands throughout the east slope of the Cascades. But again, that's sort of a habitat connectivity and landscape connectivity objective versus kind of our region-wide restoration goals. Well, I see they're setting up next back there, so I'm happy to keep answering questions, but I don't want to hold people from the...
Yeah, I think if there are no more questions, I do think there are beverages. So Ryan will be around, and I'm sure he'd love for you to figure out climate change, and also if he could figure out all problems that TNC could solve and let me know, that would be helpful. Thank you,
Thank
Ryan.
you.